All right, this one's fun. We have two charges, Q1, Q2. It gives us some charge in the problem. We don't really need that right now, but they're on top of one another. They're 10 centimeters apart. I'm going to just go right away and go to meters because I know I'm going to have to convert that at some point. But the big thing I want us to see is that since they're opposite charges, the Q2 is the only one that's going to move. They said something about it here. The lower sphere is fixed. So Q2, this is Q2. I'm going to look at a force diagram here. We're going to have the force of the electric charge pushing up. That's an E, believe it or not. We're also going to have the weight going down, the force of gravity down. So whatever the difference is in these will be the force. I need to find my overall force. That's a big deal. And I can do that if I find the force electric. I know I can find weight with W equals mg. Then I got to throw this bad boy in F equals ma and solve for A. So let's do part 1 first, and let's find this force electric. And that's Coulomb's law, which is K, Q1, Q2. Again, there's no real, you have to do it in any order. You're going to have to find all these things before you solve anyway. So the force electric going up is K, which is 9.0 times 10 to the negative 9. And what are the units of that boy? Newton times meter squared over Coulomb squared. My Q1 and Q2 are both the same. They're negative, and it doesn't really matter at this point because we know they're going to repel, so we're going to get a force out of it. 23 times 10 to the, it's nano again, so negative 9 coulombs. And I didn't leave myself enough room. Shocker. I have another 23 times 10 to the negative 9 coulombs. And that's all over 0.1 meters. But remember, you got to square that. Throw that in your calculator, and you're going to get about 4.76 times 10 to the negative 4. I hope you guys are doing these at home so you know your calculators are working. So that's my force up. So now let's find our force down. And I'm going to give myself a little room here. I don't know, let's call this, 1A or something? 1B? We need the force down. That's W equals mg. That's the weight of the object. The mass is 0.15 grams. So that's a lot of moving. That's going to be, let's go over here. 0.15 grams. I'm going to have 3 more zeros on there. So 1.5 times 10 to the negative 4th kilograms. And gravity's 9.8 meters per second squared. Let's throw that in our calculator. 1.5 EE negative 4. Let's multiply that by 9.8 and get 0.00147 newtons. I'd probably want to say 1.47 times 10 to the negative 3 newtons. And now I've got to subtract these out because I have up and I have down. So this is going to be negative. The top one is positive. So 4.76 EE negative 4. And I have to subtract off 1.47 EE negative 3. These are the two numbers I'm subtracting. And this turns into negative 9.94 EE negative 4th. So that's my overall, it's a negative number, so it's down. We know that's down because it's falling. Let's get into really what they want to know here. I'll go red now for the whole problem. I need A equals F over M because they want to know the acceleration. This was newtons, sorry, forgot a unit there. This is negative 9.94 EE negative 4. Remember I got yelled at from kids in AP2 last year for doing that. And my mass is, didn't we do this before? Wasn't it 1.5 times 10 to the negative 4 kilograms? Let's throw that in our calculator. Not point, 1.5 EE negative 4. So I divide that out and I get negative 6.6, I don't know, 3 if you want to play along, meters per second squared. So a lot going on here. We had to convert units. We had to do up. We had to do down. Force diagram, acceleration. Good times. Bye-bye.